In this video, I'll be teaching you guys how to solve weak acid calculations. I'll be giving one example and following it exactly of how I would solve it and how I was taught to solve it. Here's an example of a weak acid calculation problem. A 0.025 molar solution of an unknown weak acid has a pH of 2.5. What is the H plus? What is the OH minus? What is the POH? Calculate the undissolved HA, and calculate the Ka. Before going about to solve this problem, you'll want to remember some specific equations that will help you. The 5 equations that you'll want to keep in mind are the 1 times 10 to the negative 14 equals H plus times OH minus, pH equals the negative log times the H plus, POH equals negative log times the OH minus, 14 equals the POH plus the pH, and the Ka equals products over reactants. Step 1 is to find the H+. First, what you're going to want to do is to figure out what information you're given. In this example, we are given that the pH equals 2.5. Next, identify the equation that would be most suitable for the problem. In this case, we can use the pH equation, which is pH equals the negative log times H+. Because we are given that the pH is 2.5, we can plug that in to the equation and solve using algebra to find the H+. By plugging in what we are given, we'll get the 2.5 equals negative log times H+. Negative 2.5 equals log times the H+, and then we'll have to do an anti-log, which is 10 to the negative 2.5 equals the H+. You'll plug that into your calculator, and when you plug it in, you'll get your answer. You'll round it up to 3 sig figs, which should be 0.00316 molar. The next step is to find the OH minus. Remember that we just found that the H plus equals 0.00316. Going back to our equations, we can use the 1 times 10 to the negative 14 equals the H plus times the OH minus because we found the H plus already, and that will help us find the OH minus. You'll plug it all in and solve using algebra, which will help you find the OH minus. Plug that into your calculator, and the OH minus comes out to be 3.16 times 10 to the negative 12. The next step is to find the POH. I've put all the information that we have found so far and or that we were given in order to help us. We can use 2 different equations. It doesn't matter which one we use, they will both be effective. We can either use the POH equals the negative log times the OH minus, or we can use 14 equals the pH plus the POH. You plug in the information into the equations and you will get the answer. The answer comes out to be 11.5. Step 4 is to calculate the undissolved HA. For step 4, you're going to want to plug in the value of the H plus to the ICE table. I stands for initial change in equilibrium to find the undissolved HA. Write out the equilibrium equation to put at the top of your ICE table. In this case, HA is going to be on the reactant side, and on the product side will be H plus A minus. Now that our ICE table is set up, we're going to want to fill in the first row first, which is the initial. We can look back at our problem to find the initial value of the HA. It states that the initial value of the solution is 0.025. Then in our other 2 values, we know that they start out as 0 because they were not created yet. Next, we need to fill in the equilibrium section. We can start out by filling in the H plus because we found that in step 1. Now to fill in the change portion, we can look at what it started at, which was 0, and look at what it ended at, which is 0.00316. In the product section, it went up 0.00316. So that means in the product section, it is adding 0.00316 on both sides. Now because there's no coefficients, we don't have to multiply those by anything. Now, on the opposite side, going the opposite way, that means on the reactant side, it would be subtracting 0.00316. You'll plug that into your calculator and you will get 0.0218. Finally, the last step is to calculate the Ka. We could look back at our equations and look at all the ones that we could possibly use. We've used a lot throughout this problem, but the last one that we can use is the Ka equals the products divided by the reactants, which is the H plus times the A minus divided by the HA. To make it easier, I rewrote our ice table at the top. The ones I've highlighted are the values that we are going to be using, which is our equilibrium values. We will plug these into our equation in order to find the Ka. When plugging all of these values in, you'll plug this into your calculator. When plugging into your calculator, you will get that the answer is 0.00458, or 4.58 times 10 to the negative 4. I want to emphasize that this method is only used for weak acids. You cannot use this method for strong acids because they are completely dissolved. Thank you for watching. I hope this helped.